Okay, let us revise this paper. This one is the Kenya National Examination Council, Kenya Certificate of Secondary Education Mathematics, Paper 1, Alternative A, November 2018, 2.5 hours. So here are a number of instructions. Number A, write your name and index number in the spaces provided above. B, sign and write the date of examination in the spaces provided above. C, this paper consists of 2 sections, Section 1 and Section 2. D, answer all the questions in Section 1 and only 5 questions from Section 2. But E, show all the steps in your calculations, giving your answer at each stage in the spaces provided below each question. F, marks may be given for correct working even if the answer is wrong. G, non-programmable silent electronic calculators and Kenya National Examination Council mathematical tables may be used except where stated otherwise. H, this paper consists of 18 printed pages. I, candidates should check the question paper to ascertain that all pages are printed as indicated and that no questions are missing. J, candidates should answer the questions in English. So let us begin with the first section, and this is it. So question number 1, without using a calculator, evaluate. Without using a calculator, evaluate. So we are to evaluate this particular question here. So as far as it is concerned, here we are going to divide our space. We are going to divide our space. We are going to divide it like this. And then we start with the upper part. We call it the numerator part. So for the numerator part, I'm having 2 and a third minus 1 and 1 over 5 of 2, like this. So as far as it is concerned, I'm going to convert these mixed numbers into improper fraction. That is the first step. And how do we convert these ones? I'm going to take 3 times 2, which is 6, and 6 plus 1, this gives us 7. So it is going to be 7 out of 3, like that, minus 5 times 1 is 5, and 5 plus 1 is 6. So I write 6 over 5 here, and then of this one is 2. At this point, I'm going to apply the rule of BODMAS. After converting all the mixed numbers to improper fraction, it is when we are going to apply BODMAS. So we don't have bracket, in this particular case, but we have the off part, which is this one here. So it is 6 over 5. Off means multiplication, so we multiply by 2. So this will be 2 over 1. If it is a whole number, to make it as a fraction, we divide it by 1. So these numerators are going to multiply. 6 times 2, this gives us 12, and 5 times 1, this gives us 5. So we're going to have 12 over 5 at that point. But remember, here we had 7 over 3. So it is 7 over 3 minus. So 7 over 3 minus 12 over 5. So at this point, if we are subtracting fractions, we have to consider what is called the LCM. So the LCM of 3 and 5, the LCM is 15. We write it here. So 15 divided by 3 is 5, and 5 times 7 is 35. We write it here, minus 15 divided by 5 is 7. 15 divided by 5, is 7, and then 7 times 12, we are going to have, if we have 15 divided by 5, we are going to have 7. And 7 times 12, we are going to have 84. We are going to have 84. So we write 84 here, like this. Therefore, we are going to have 35 minus 84. We are going to have 35 minus 84. So 35 minus 84, this is what we are going to have. We are going to have negative 49 here, negative 49. So we are going to have negative 49, all this over 15. Negative 49 over 15. Negative 49 over 15. Remember, we had converted these ones into mixed number. 3 times 2 is 6, and 6 plus 1 is 7. 7 over 3 minus 5 times 1 is 5, plus 1 is 6. 6 over 5 of 2. So if we multiply here, we are going to end up with 12 over 5. So 7 over 3 minus 12 over 5, we say the LCM is 15. 15 divided by 3 is 5, and 5 times 7 is 35. And 15 divided by 5 is 3. 3 times 12 is 36. Here we should have 36 and not 84. Sorry, here we should have 36. So it will be 35 minus 36, all this over 15. Yeah, this is what we are going to have. Remember, 15 divided by 5 is 3, and 3 times 12 is 36. So 35 minus 36, this will give us -1, and it will be -1 over 15. -1 over 15. That is the numerator part. For the denominator part, it is 1/4 minus -1 over 2 power 3. So for this case, we are going to have 1/4 here minus, so -1 over 2 power 3 is the same as -1 over 2 times another -1 over 2 times -1 over 2. So negative times negative will be positive, and positive times negative will be negative. So we're going to have 1/4 minus, the answer here will be -1, and 2 times 2 times 2 will be 8. So minus and minus become plus, which will be 1/4 plus 1 over 8, like this. So the LCM here is 8. 8 divided by 4 is 2, plus 8 divided by 8 is 1. 1 times 1 is 1. This will give us 3 over 8, the denominator part. So we'll come here and finalize. We'll have the numerator part, which is -1 over 15, divide by the denominator part, which is 3 over 8. This will bring us to -1 over 15 multiplied by the reciprocal, which is 8 over 3. And this will be -1 times 8 is -8, and 15 times 3 is 45. So this becomes the final answer. The final answer becomes -8 over 45. So we are done with the first question. So for the second question, we are given that 6 power 2n minus 3 is equivalent to 7,776. We are to find for the value of n. So here we'll come here and say 6 raised to power 2n minus 3 is all equal to 7,776. So because this number is to base 6, we can express this one also to base 6. And 7,776 to base 6, it is 6 power 5. So this will give us 6 power 2n minus 3 is all equal to 6 power 5, like this, 6 power 5. So at this point, because these bases are the same, we are going to ignore them and put into consideration of the powers. The powers here are 2n minus 3 is equals to, we have this power here, 5. So collect the like terms. We take this -3 to this side, it will be positive. So this gives us 2n is equivalent to +5, and then we add 3. We add 3. So this will bring us to 2n is equals to, so 5 plus 3 is 8. We write it here. We divide this one by 2. We also divide this one by 2. This one and this one will cancel, so that the value of n will be 8 over 2, which is 4. The value of n will be 8 over 2, and when 8 is divided by 2, the product will be 4, like that. This brings us to question number 3. Which states that the base of a right pyramid is a rectangle. The base of a right pyramid is a rectangle of length 80 centimeters and width 60 centimeters. Each slant edge of the pyramid is 130 centimeters. Calculate the volume of the pyramid. So we have to calculate the volume of the pyramid. For this case, we need to have a sketch of the pyramid. They are saying it is a right pyramid. So the base is a rectangle. So we'll come here and have the sketch. The base is a rectangle. So this is how we are going to have that pyramid of ours. The base is a rectangle. So we are going to have a sketch of the pyramid. So the base is a rectangle. So if this one is a right pyramid, simply means we are having a point where all those slanting edges meet up here. We have a point, a common point, where all those slanting edges meet. So a right pyramid has a number of faces. There are 5 faces. We have 5 faces. So this one is a sketch of the pyramid. So the base is a rectangle which measures 80 centimeters by 60 centimeters. So this is it, by 60 centimeters. We are being told that each slanting edge is 130 centimeters. So from here up to here is a slanting edge. From here up to here is a slanting edge, and another slanting edge. These ones here. So each measures 130 centimeters. We write it here, 130 centimeters. So we're asked to calculate the volume. So you should appreciate that volume of a pyramid is given by the formula a third times the base area and then times the perpendicular height. So the base area, it is easy to get the base area because the bottom part is a rectangle, and you know the area of a rectangle is length times width. So the base area is given by 80 centimeters times 60 centimeters. But it is up to you to calculate this perpendicular height here. So the perpendicular height, it is that height from the top all the way to this particular part here where we have the bottom part. So how are we going to calculate that height? So you need to have this diagonal. You need to have the dimension of this diagonal. And after having the dimension of that diagonal, you are also going to include your perpendicular height here. We call it H, capital H. So for you to get this H, you need to have this length from here up to here. And for you to get this diagonal, you need to appreciate that down here we are having a right angle triangle. We are having a right angle triangle which will obey the Pythagoras theorem. So to get this diagonal, which is L for the diagonal, we are going to have A squared plus B squared is equals to C squared. So C squared is the longest side. So we can talk of L squared is equals to A squared plus B squared, like this. So A squared, we are going to have 80 squared plus B squared, we are going to have 60 squared is equals to L squared. L is the diagonal, remember. So this one becomes 6,400 plus this becomes 3,600, like that. It is equivalent to L squared. So if we add these ones, we are going to end up with 10,000 is equals to L squared. So how do we get L? We get the square root. So L will be the square root of 10,000. And the square root of 10,000, it is 100 centimeter. So the diagonal is 100 centimeter. So how do you get the height if we have the diagonal? So if we have the diagonal of 100 centimeter, from here up to here is 100. So what is a half of it? A half of it will be 50. And we need a half of it which is 50. We use it together with this slanting edge here so as to get this height. So this slanting edge will now act as our new hypotenuse. This is what we are going to have. We can just have a small right angle triangle here. Yeah, like this. And form another small right angle triangle. So the length from here up to here is 50. How 50? We take 100, we divide this one by 2. So 100 divided by 2, we are going to have 50 centimeters, which is this one here, 50 centimeters. And this hypotenuse will be the slanting edge, which is 130 centimeters. It is here. So we are looking for this height here. So how do you get this height? Again, we use the Pythagoras theorem. Now we are looking for this smaller length here. It will be H squared. It will be given by the longer length, which is 130 squared minus 50 squared. So if we square this one, we're going to have 169 with 2 zeros minus 5 squared is 25 with 2 zeros is equals to h squared. So if we take 169 minus 25, we know it is 144. The two zeros are going to occur, is equals to h squared, like that. So for you to get h, it is the square root of 14400, and the square root becomes the square root of 144, we know very well it is 12, and the square root of 100 is 0. So the square root becomes 120 centimeters. If that is 120 centimeters, we'll come here and say now the volume is a third times the base area. It is 80 times 60. So we write 80 here, we write 60, and then times the height. The height is 120. So if we multiply by 3, 1 by 3, 20, 60 by 3, we are going to have 20, like that. So if we multiply 80 times 20 times 120, we are going to have 192 with 3 zeros cubic centimeters. This will now be the volume of that pyramid, the volume of that pyramid. So you need to have the sketch, and then from this sketch you are to calculate for this particular diagonal. So this diagonal, we obey the Pythagoras theorem, and then we divide it by 2 because we need to have a half of it. And then after dividing it by 2, we use this 50 centimeter we are going to obtain here together with the slanting length, which is 1/3, to calculate the perpendicular height. And then from this height, using this particular formula, we are going to obtain our volume as 192,000 cubic centimeters. That will be the volume of the pyramid. This brings us to question number 4. So question number 4, we are having a figure here. They are saying in the figure below, ABCDE is a uniform cross-section. It is a uniform cross-section of a solid. Given that FG is one of the visible edges of the solid, FG, it is one of the visible edges. They are saying complete the sketch showing the hidden edges with broken lines. Complete the sketch showing the hidden edges with broken lines. So this is how we are going to complete it. So from this particular point E, we are going to draw a line which is parallel to FG. So this will be the line, like that. And then from this point, we also draw another line which is parallel to the given line there. We're going to have it like that. And then from this point, we join this point to this point, like that. We also join this point to this point, like this. And then we're going to draw another line from point C. We're going to draw another line from point C. That is it. Then we join this line from that point all the way to that point. We join it like this. You use pencil, here you use pencil. And then from point B, we are going to have a line. We call that particular line a broken line. It will be a broken line. So for that broken line, it is a hidden edge, so it will be a broken line, like that, up to somewhere. And then again, from A, we are going to have another broken line. We are going to have another broken line, like that. So this is what we are going to have. This line, we are going to join it together with the other one which is inside there, and of course it will be broken. And then from that point, we join it to that line, and then we complete our figure. So look here, the length of this particular line, these lines we have just drawn here, their length should be equivalent to the length FG. Their length should be equivalent to the length FG. We are then going to label our diagram. So they're saying the figure is called A, B, C, D, E, and F. So we have A, B, C, D, E, F. So if this one is F, they are saying that given that FG is one of the values, so we have FG. So they are saying it is A, B, C, D, E, F. So we have G. So from G, we can talk of H. We can just have another one here. We call it H, I, J, and then K, and lastly L, alphabetically. So this is what we are going to have as our figure. So this one is the complete figure. Question number 5. The lengths of 3 wires were 30 meters, 36 meters, and 84 meters. Pieces of equal lengths were cut from the 3 wires. Calculate the least number of pieces obtained. So we have to calculate the least number of pieces obtained. So as far as it is concerned, also, we need to have a number, the highest number which can divide 30, 36, and 84. And we call that number the GCD. So we are to look for the GCD of 30, 36, and 84. So how do we arrive at the GCD of 30, 36, and 84? So for you to arrive at the GCD of 30, 36, and 84, we are looking for a number which can divide all these ones, and that smallest number possible which can cause the division here, it is 2. So if we divide by 2, 30 divided by 2, we are going to have 15, and 36 divided by 2, this will be 18, and 84 divided by 2, we are going to have 42. We also look for another number which can divide all these ones, and the number is 3. 15 divided by 3 is 5. 18 divided by 3 is 6. And 42 divided by 3, it is 12. Not 12, but 14. It is 14. It is 14. So the GCD will be 2 times 3. Know very well that 2 times 3 is 6. So if these are the 3 wires, we are having their lengths here as 30 meters, 36 meters, and 84 meters, pieces of wire of equal length. So each of the piece which was cut was 6 meters long. Pieces of wire of equal length. So each of the piece was 6 meters long. So how do we get the total number of pieces we have obtained? For the first wire, we are going to have 30 meters divided by 6 meter piece. And then for this will give us 5 pieces. This will give us 5 pieces. And then for the second wire, which measured 36, we are going to have 36 divided by 6. So that 6 divided by 6, this will give us 6 pieces. And lastly, 84 meter long divided by 6, this will give us 14 pieces. So we are to calculate the least number of pieces obtained. So all those pieces obtained were 5 pieces plus 6 pieces plus 14 pieces. This gives us a total of 25 pieces which were obtained. 25 pieces were obtained. And then question number 6. Question number 6. Question number 6. We are being told that a 2-digit number is such that the sum of its digits is 13. When the digits are interchanged, the original number is increased by 9. Find the original number. So a 2-digit number. So let the number be AB. For the value of this number, the A is the ones place value. The B is the ones place value, and the A is the tens place value. So its value will be 10 times A. 10 times A, this dot means times, plus 1 times B, the value of the original number, that is before the interchange. So 10 times A is 10A, plus 1 times B is B. So that is the original number. But look here, the sum of its digits, the digits were A and B. The sum is 13. So if we have A plus B, we should be able to get 13. We call it the first equation here. Write it there. When the digits are interchanged, so if we interchange these digits, we are not going to have AB, but we are going to have BA. So this A will now be the ones place value, whereas the B changes from the ones place value initially to the tens place value, like this. So the value of this number it is not going to be 10a plus 1b. Instead, it is going to be 10 times b plus 1 times a. Dot means time. So the value will be 10b plus a. So they're saying when the digits are interchanged, the original number is increased by 9. So it simply means that if we have this value and you compare it to the original value, the value of this number is 9 more than this one. The original number is increased by 9. So what we are going to say here is that if we take this new value minus the original value, we should get 9. So the new value is 10b plus a, and the original value is, we subtract 10a plus b. This one is the original value. We should get 9. So let us open the bracket here. This will be 10b plus a minus 10a minus, remember minus times positive is minus, minus b is all equal to 9. So 10b minus b, this will give us 9b. And then plus a minus 10a, we are going to have negative 9a is equivalent to 9. So because here we have 9, 9, 9, we can divide all through by 9. So if we divide this equation by 9, this will be 1b minus 1a is equivalent to 1. We call it the second equation. So the first one was a plus b. So from equation 1, we can just make one unknown to be the subject. If a plus b is equals to 13, we can say a is equals to, so we take this b to the other side, 13 minus b. It is positive. When it crosses an equal sign, it becomes negative. So 13 minus b. At this point, since a is 13 minus b, we are going to substitute this one in equation 2 now. And equation 2 states that b minus a is equals to 1. But our a is 13 minus b. So it will be b minus, instead of a, we substitute for 13 minus b here. And then the equivalent answer will be 1. So this will be b minus 13. Minus and minus become plus, b is equals to 1. So b plus b, this gives us 2b is equivalent to 1. Because this is minus, when it crosses an equal sign, it becomes plus 13. So 1 plus 13 is 14. So we're going to have 2b is equals to 14. So if 2b is 14, then we divide by 2 to get b. So the value of b will be 7. The value of b will be 7. So if our b is 7, what of a? Look here. A plus b is equals to 13. A plus b is equals to 13. So b is 7. So a plus 7 is equals to 13. So you take this to that side. So a will be equal to 13 minus 7. 13 minus 7 will be equal to 6. So the number was ab. So if the number was ab, our a is 6 and our b is 7. So the original number was 67. Original number was 67. We are done with question number 6. Let us go to question number 7. So question number 7, using a ruler and a pair of compasses only, construct a quadrilateral PQRS in which PQ is equals to 5 centimeter, PS is equals to 3 centimeters. So we are not going to do this part of this question. I mean, why? Because we don't have a mathematical set right now here. So this brings us to question number 8. For question number 8, we are being told that given that the column vector OA is 2, 3 and the column vector OB is negative 4, 5, find the midpoint M of AB. The midpoint M of AB. So for you to get the midpoint, we can use the midpoint theorem that I have A and B as the points given, and all these ones are originating from O, a common point. They are originating from O, a common point. So if this is O, I have A and B. So the column vector OA, it is given as 2, 3, and the column vector OB, it is given as negative 4, 5. We are being told that M is the midpoint of AB. Midpoint simply means it is at the center of this line. So if you want to get the coordinate of this point, we apply the midpoint theorem in vector 1. We state that the coordinate of M is given by the first x plus the second x over 2, comma, and then the first y plus the second y also over 2. So the first x is this one and the second x is this one. So it is 2 plus negative 4. We divide the result by 2, comma, and then the first y is 3 plus the second y is 5. We divide what we are going to have our sum, we divide it by 2. So 2 plus negative 4, we are going to have negative 2. So it will be negative 2 over 2, comma, 3 plus 5 is 8. It will be 8 over 2. So negative 2 divided by 2 is negative 1, comma, and then 8 over 2 is 4. So the coordinate M, which is the midpoint, will be negative 1, comma, 4. Negative 1, comma, 4. So we are done with question number 8. So question number 9. For question number 9, we are being told that two towns, R and S, are 245 kilometers apart. A bus traveling at an average speed of 60 kilometers per hour left town R for town S at 8 a.m. A truck left town S for town R at 9 a.m. and met with the bus at 11:00 a.m. Determine the average speed of the truck. Determine the average speed of the truck. So, for this case, we are going to have a sketch of the towns, and they are 245 kilometers apart as per the question. They are 245 kilometers apart. So, let us have a sketch. We can just have a straight short line here. And then at one end, we are going to indicate town R. Then at the other end, we are going to indicate town S. So the distance between these two towns, or they are 245 kilometers apart. 245 kilometers apart. We have a bus which is traveling at an average speed of 60 kilometers per hour, left town R. So the bus left R. At what time? At 8 a.m. So the departure time for the bus is 8:00 a.m. from town R, that is at a speed of 60 kilometers per hour. So we are writing the information given. A truck left town S for town R. So we have a truck departing from S to R at 9 a.m. at an average speed. We don't have the speed, but the time is 11:00 a.m. Not 11, but 9:00 a.m. The departure time, 9:00 a.m. So we are being told that this truck met with the bus at 11:00 a.m. So for you to determine the average speed of the truck, you should ask yourself, what is that distance covered by the truck from 9 a.m. all the way to 11:00 a.m. when the two met? So for you to get this distance, you should ask yourself, before the truck started its motion, remember here we have the bus, and on the other hand we have the truck. We are to calculate the distance covered by the bus, because the bus is the one which started its motion earlier by 1 hour. We are to calculate the distance covered by the bus from 8 a.m. all the way to 9 a.m. So this one is a period of 1 hour. We have 9:00 a.m. minus 8:00 a.m. This will give us 1:00. So it is 1 hour. So distance covered by the bus within 1 hour, that is from 8:00 a.m. all the way to 9:00 a.m. So distance is speed times time. What is the speed of the bus? It is 60 kilometers per hour. We multiply by 1 hour. So hour and hour will cancel. We are going to remain with 60 kilometers. So the bus traveled a total of 60 kilometers per hour. That is from 8 a.m. all the way to 9 a.m. So if the distance between them was 245, we have to subtract 60 kilometers from the 245 to come up with the remaining distance. So for the remaining distance, we'll come here and say, if I take 245 kilometers and then I subtract 60 kilometers, the remaining distance, this one is 5, this one is 8, this one is 1. The remaining distance will be 185 kilometers. So by 9 a.m., the bus and the truck were 185 kilometers away from each other. 185 kilometers away from. So here we have 900 am and here we have 900 am. This one is B for the bus, this is 3 for the truck. This distance is 185 kilometers. We are given the speed of the bus as 60 kilometers per hour, but we don't have the speed of the truck. It is unknown. So again, we'll come here and say, because they all met at 11:00 am, 11:00 am. So ask yourself, from 9 a.m. to 11:00 am, how many hours are those? Those are 2 hours. So you come here and say 11:00 am minus 9:00 am. You have a total of 200 hours. So for these 200 hours, let us calculate the distance covered by the bus, and then we are going to subtract it from 185 again to have the remaining distance. That remaining distance is the distance covered by the truck from 9 a.m. to 11:00 am. So distance for the bus again, it is speed times time. The same speed, 60 kilometers per hour, but the time is now 2 hours. So hours and hours will cancel. This will give us 120 kilometers. If this is 120 kilometers, it was 185 kilometers. We take 185 kilometers minus 120 kilometers. So 185 kilometers minus 120 kilometers, we are going to remain with 65 kilometers. So it simply means the tract covered a total of 65 kilometers from 9 a.m. to 11 a.m., a total of 65 kilometers. So what of the speed now? So the speed, it is usually given by distance over time. Now the speed of the truck, it is the distance covered by the truck, which is 65 kilometers, and for the time it is 2 hours. Why 2 hours? Remember, it is 9 a.m. to 11 a.m. Those are 2 hours. So if we take 65 divided by 2, we are going to have 32.5. We are going to have 32.5. So I'll come here and say the speed of the truck is 32.5 kilometers per hour. 32.5 kilometers per hour. This brings us to question number 10. And for question number 10, they're saying in the parallelogram, WXYZ below, WX is 10 centimeters. So from W to X is 10 centimeters, and then XY is 5 centimeters. Angle WXY is 150 degrees. We are to calculate the area of this parallelogram. So for this case, again, this is what we are going to have. How do we get the area of this parallelogram? This is what we are going to have. We can just say it is like a tilted rectangle. A tilted rectangle is the one we can call it a parallelogram. Tilted rectangle. So this is the sketch. Trying to have it here. This is the sketch of the parallelogram. So we all know that the area of a parallelogram is given by the base length times the perpendicular height. But in this case, we are not given the perpendicular height. So how are we going to calculate the area? We are given this base length of 10 centimeters, and the other side is given as 5 centimeters. The angle in between these two sides is indicated here as 150 degrees. This one is W. Here we have X. Here we have Y and Z. So we need to join W to Y. That is the longest diagonal. We need to have this longest diagonal here, which is called WI. And this longer diagonal, it is dividing our parallelogram into two equal triangles. We have this triangle which is called triangle WXY, another triangle which is called triangle WZY. So the area of this triangle WXY, it is equivalent to the area of the other triangle WZY. So we need to have the area of this triangle down here, and then we multiply it by 2 because those two triangles share the same area. So for the area of a triangle given two sides and an angle which is included between the sides, area will be given by a half and then AB sine theta. This. So it is a half times our A is 10 centimeters, our B is 5 centimeters, and then sine 150 degrees. The angle is 150. So we divide this one by 2 by 2, we're going to have 5. So 5 times 5 is 25. 25 sine 150. So the sine of 150 degrees is 0.5. So it will be 25 times 0.5. This gives us 12.5 centimeter square. So this one is area of the first triangle. For the total area now, we have to multiply by 2 because we have two triangles there. It will be 12.5 centimeter square multiplied by 2. This will give us a total area of 25 centimeter square. So this one is the area of this parallelogram, 25 centimeter square. So we are done with question number 10. This brings us to question number 11. So for question number 11, without using mathematical tables or a calculator, evaluate. So we are to evaluate this particular question. We are to evaluate this question here. So sine 30 degrees minus sine 60 degrees over tan 60 degrees over tan 60 degrees. So this is what we are going to have. So here we are going to consider an equilateral triangle which measures 2 units. The side measures 2 units. This is all about trigonometric ratio of special angles. So we are going to consider an equilateral triangle, and this one is it is a topic in Form 2 under trigonometry. So trigonometric ratios of special angles, we consider an equilateral triangle which measures 2 unit by 2 unit by 2, like this. So each of this angle will be 60 degrees. So if it is an equilateral triangle, each of those angles measure 60 degrees. We are going to bisect this particular angle here, and we let this perpendicular bisector to meet the base at a certain point. So the length from here up to here will be 1 unit, and then from here up to here is the hypotenuse. We are asking ourselves what will be the perpendicular height. So for the perpendicular height, we are going to employ the Pythagoras theorem, which is a squared plus b squared is equals to c squared. So we have the c squared. So to get the height, it will be c squared or 2 squared minus 1 squared is equals to h squared. So 2 squared is 4 minus 1 squared is 1 is equals to h squared, the Pythagoras theorem. This gives us 3 is equals to h squared. So for you to get the height, it is root 3. It is root 3. So this height here is root 3. So the angle here will not be 60. Instead, it is going to be a half of 60, which is 30 degrees. And this angle down here will be 60 degrees, like this. So if you are to look for sine 30 degrees, we know the sine of an angle is opposite of a hypotenuse. Sine is equals to opposite of a hypotenuse. So sine 30 degrees will be, we have 30 degrees here. So the sine is opposite is 1 and its hypotenuse is 2. So sine 30 degrees is a half. We write it here. And then sine 60 degrees. Sine 60 degrees, also opposite of hypotenuse. So 60 degrees is this one. Its opposite is root 3 and hypotenuse is 2. So I write it here, root 3 over 2. What of tan 60 degrees? So tan 60 degrees, also tan is given by opposite of adjacent. So the opposite, 60 degrees is this one. The opposite is root 3 and the adjacent is 1. So if we have a number divided by 1, we're just going to remain with root 3, like that. So let us now substitute for these ones in this part of our question. Sine 30 degrees, we write a half, like this. And then minus. Sine 60 degrees, we write root 3 over 2. And then all this over tan 60 degrees, which is root 3. So because the denominator is root 3, we can rationalize it. And we are going to rationalize it by multiplying this denominator by the same root, which is root 3, and we come up here and multiply by root 3 also, the numerator part. So we're going to have, for the numerator part, a half times root 3, it will be root 3 over 2. Remember, this one is over 1. So it will be root 3 over 2 minus root 3 over 2 times root 3. This will be root 9 over 2. And we know very well that root 9 is 3. So it will be 3 over 2. This is for the numerator part. And for the denominator part, root 3 times root 3, we are going to have root 9, which is 3. Which is 3. Root 3 times root 3. This will give us root 9, and root 9 is 3. So we have this numerator divided by the denominator. So the numerator is root 3 over 2 minus 3 over 2. And then we divide all these ones. Let us have the horizontal division. We divide all these ones by 3. So I'm going to have root 3 over 2 divided by 3, and then minus 3 over 2 divided by 3. So this will be root 3 over 2. If we are dividing this one by 3, we simply means we multiply by the reciprocal. The reciprocal of 3 is 1 over 3. And then minus 3 over 2. Again, if we are dividing this one by 3, we multiply by the reciprocal, which is 1 over 3, like this. So this one will be root 3 times 1 will be root 3. We write it here, and it will be root 3 over 6. And then minus 3 times 1 is 3, and 2 times 3 is 6. 3 here, all over 6. 3 over 6, not 2, but 3 over 6. So because they share the same denominator, we can just have root 3 minus 2, all this over common denominator, which is 6. Root 3 minus 2 over, root 3 minus 3. This is 3, not 2. Root 3 minus 3, all this over 6. Root 3 minus 3 over 6. Root 3 minus 3 over 6. So let us leave this particular paper of ours at this particular question, question number 11. We shall come and continue from this particular question, that is question number 12, all the way to the last question.